If we have a p-value, it means we collected some data and compared two numbers. The numbers may be something we calculated, like the slope of a regression line, and a specific value, like 0. Or the numbers may be two values we calculated, like the average quality of life before and after a mindfulness intervention, or the average weight loss for a group of people who got an exercise intervention and those who didn't. The p-value is a measure of how likely it would be to get the values we observed if the real difference between the values was 0. A really small p-value means it would be really unlikely to collect the data we recorded if there wasn't a real difference between the numbers. A really large p-value means we would be very likely to collect the data we recorded if there wasn't a real difference between the numbers. For example, suppose we want to determine whether OT students at Duquesne are taller than OT students at the University of Pittsburgh. We can start by measuring some Duquesne students and some Pitt students and getting the average height of both samples. At this point, we have two numbers, the average heights of students at Duquesne and Pitt, calculated from a sample of all the students who ever have or will go to Duquesne or Pitt to study OT. If we assume that there is really no difference in the average height of OT students who go to Duquesne and Pitt, we can calculate how likely we are to get the average values we obtained from our two samples. Assuming there is no difference in heights between schools, getting two values that are close together is very likely. In fact, the closer the values are, the larger the p-value gets. On the other hand, assuming there is no difference in heights between schools, values that are far apart are less likely. So the further apart the two values are, the smaller the p-value gets. At some point, the p-value gets small enough that we are willing to rule out the possibility that students at Duquesne and Pitt